Okay, there's that, and we're done. Okay, let's get started. So the last time we wrote this thing for heterogeneous lists, and basically we're just going to finish this and then move forward. So, actually there was something that we needed to check with respect to HList, and I don't remember what it was, but I know that it was in Discord. So let me go look for that real quick, and then we'll verify whatever was broken. I don't think that it was broken necessarily, but we were curious if something would compile. Okay, so the question was, for htail, what will happen if we give it hnil? And I don't think we can. I think it will be a type error because we're explicitly expecting at least a single element. So my guess is that when we put this thing up in the REPL and we type htail of hnil, we'll get a type error, which I think was the idea. I think that's what we wanted to happen. Yeah. So let me copy and paste this into the Discord, and then we'll keep going. There we go. Okay, done with that. Whoa! On a plane, about to take off back home. Going to miss another stream. Unfortunate, new made. But, you know, again, we'll be on YouTube, but I know you like to watch when it's live. But we did learn what's going to happen with this, by the way. It turns out to be a type error, which is pretty useful, I suppose. So you can't even call htail without a single element. So you'd have to call... what was it? :sharp, I think? Not Google. Yeah, :sharp. Oh, well, okay. First we need to implement this. No instance for show empty list. Oh, okay. So h format appears to have compiled. So this should be in, yeah. So if I write h format source lib, why do I need existential quantification in this module? Is this like a template Haskell thing that I just don't understand? It might be. So we could enable it for the whole thing, if I remember correctly, by putting it in package YAML and just see what happens. So for whatever reason, I liked H format quite a bit because it does a little bit more than stylish Haskell seems to do. It uses stylish Haskell, but I think it uses other things. But I don't remember how to do this necessarily, so let me look this up real quick. So add language extension to package.yaml. Here. Default extensions. Oh, I don't need to do this here. I can do this right here. Package YAML. Default. And we need this one. Whoops. Oh my goodness. Okay. So now if we do this and this, what are we trying to do? Oh yeah. We need it to make the right Cabal file, I suppose. I don't understand why this is failing. I thought that would just work if I had default extensions on. But okay. What does this do? It doesn't change the error. I don't understand what this is about. So anyway, I'm not going to worry too much about it. We'll just remove the existential quantification thing. And we don't need this. Okay. And then that works. Great. So I think we're just using stylish Haskell, but that's totally fine. So the next thing we need to do is implement a show instance so that we can actually print these things. So let's do that down here, I suppose. We don't really need this. So we need instance show. It's going to be very similar to this eq instance. Show t, show. So show t so what we need to do is we need what do we need? What we would like to do is show this as an actual list. So I think that we need to write some sort of other function that does the recursion. Otherwise, we're gonna have a problem. And also, is h nil? Yeah, one of the things we have to do is derive show. So this is part of the thing we need to do. What am I using this bh list for? I'm not using it for anything, so let's get rid of it. So I need to show T, but I also need to match H nil. So show and H nil equals like a string H nil, I suppose. And then here what we want is like we want it to look like a list. But I guess we really want, how do we want it to look? Probably like this. Oh, right. This isn't correct. Because we're explicitly doing this. So we're gonna have two show instances. That's how this is gonna work. There's gonna be a show instance for what did I just do? There's gonna be a show instance for this. And then there's also going to be an instance of show for H nil. So show and anything will just end up being H nil. So H nil would go here? Okay, that's right. I'm just trying to make sure I understand this correctly. All right, so essentially I think we need some sort of do function. So we're gonna say where do, or go, not do. Show T plus go TS. And then we'll put go in here. Let's just write it out. It's totally fine for now. So what's the type of Go here? So I noticed somebody just popped in, so let me tell you what's going on. Basically what we're trying to do is implement show for a heterogeneous list. So in Haskell, you can build a heterogeneous list by essentially including all these fancy language extensions, and then generate a heterogeneous list at compile time. So it's a little tricky to play with them because you have to do things like this, where this T is a some type, so you need to be able to pattern match on this T, so it has to have a show instance, and then you also need to have like a recursive show. So this is, I think this is actually recursive in TS, so it's pretty wild stuff. But right now we're having a type error because we can't add. You can see some weird errors in here, I'm sure, or what are going to be end up being weird errors. So what's the type of Go, and what's P here? Shouldn't we get a string? What if we just make this show T? P is untouchable. It's probably because these T's aren't the same. So I think I actually do need to make them the same. So I think we need that scoped type variable. Oh wait, we have that. So we need we put that here. We're all TS. Can we put that there? For all TS. P is untouchable. Okay, let's get rid of this and just put show T in here. And then let's try and run these two things, because I don't quite understand how we do this recursively and still add without adding extra parentheses. Right, that's the key. Because if we add extra parentheses here, that's not what we want. We'll have like infinitely embedded parentheses. I keep saying parentheses, but it's not. They're brackets. So let's see if this works for one element and see what it looks like. So I don't have that there, I guess. So we want to print hlist. Well, that. And if we just print hnil, we should get hnil. And is it correct to add this? I do not think so. I think that it's like this. So one thing we could do is just go look at how the regular show instance for string is written. Go from there. Or this didn't do anything, it seemed. Thought that would work. How do we get this TS? Let's just go look at the show instance list. Might give us a trick. Base. I don't understand. How can that not be in Hoogle? Shouldn't it be like this somewhere? Was list defined? Go in here, I guess. Right there. Yes. So show. I have no idea. I just kind of assumed this would be in here, but it's not. Weird. Okay. One thing I saw in here, which I thought was strange. GHC show. Sometimes reading this is pretty hard. But okay. What if we just look for, oops. New idea. Look for the concatenation operator. Cons. I said concatenation. That's not concat. Cons. But I guess in base. I'm very confused right now. How is that not? Where is this? List. Data? Category? I'm super confused right now. How come I can't find this operator? If anyone knows, let me know. I'm very confused. Seems to me like I should be able to find the cons operator. But I can't. So, okay. We'll figure it out ourselves. I mean, it's basically just... should just be show TS, I suppose. But this isn't quite what we want. Because we really want to A start and end. What does this do? Am I just thinking about this incorrectly? It's not going to embed those? Yeah, that's what I thought. How do we get it to not embed those? That's why I was thinking we need a go function. But then maybe if I that's why I was thinking I need the scope type variables. That's what I was thinking. Because then you can use the for all to just have a go function, but that didn't work. This compiles, but then if you have go t ts show t plus plus comma plus plus go ts. Did we do this before? We've done stuff like this. I think we need something like that. Let's try it that way. At it does the same thing. This is tricky. This is definitely tricky. Because it doesn't appear like my for all is working the way I want it to. Oh, we wanted to test this h last with h nil. Just realized we tested the wrong thing. Not sure how to think about this. The error doesn't mean anything. That's the biggest issue. These errors are going to be really hard to understand, I think. Right. if I just make this show? What if we just make this something else and move this for all? Oh, same error. Expected type P, the actual type car. Very confused. Expected type P. Why is it expected type P? Should be go takes H list T TS and produces a string. This just works. It's kind of hilarious. Right, that's not the right thing. Okay. I mean, let's try this. I'm not sure that this is correct, but I assume this is the right pattern to make these work. Hey, I just noticed a bunch of people popped in. How's it going? We're on our path to affiliate. Right now, we are working on implementing the show instance for the heterogeneous list, and it's kind of cool. I wonder if we make the for all. Let's get rid of this and put the for all back. TTS. Same error. I thought that that's the scope type variables thing. Let me go poke with that again. Because I thought that's what it would be, but it seems to not be liking that. That was in chapter what? 2? Where was that? Not data kinds. So I think it was chapter 3. Excuse me. Yes, type scoping. Scoped type variables. Yep, got that. And then we also have type application. Yep. So let me make sure I look at this correctly. Maybe I'm not thinking about this right. I guess I'm not thinking about this right, but that's okay. This seems to be working with the... We are using scope type variables, so I think these T's are the same. But this seems to be okay. So let's try this. Reload, and then print. Yeah, this won't work because I'm calling show. I need to call go here. Okay, so we need to do this trick again. No. This. Hey, do I pronounce that Emily Pie? From the Discord fame, I suppose? Do you feel famous from Discord? Nick is your taken? Okay. Hey Nick, how's it going? We are trying to figure out how to write this, and we are doing it wrong. But that's okay. Because, I do a lot of things wrong. Internet famous. Isn't that the worst kind of famous? Yeah, we're making heterogeneous lists. So we have this data type up here, which basically just represents our heterogeneous list. And, it's a list of some type, and it can be any type. So you can either have an H nil, which is obviously, empty list, or nil in our case. And then you can have some cons operator to put them all together. So you can do interesting things like, have correct compile time htail, right? Which is neat. This won't allow you to put in like an empty list because the type signature doesn't allow you to. But I'm a little stuck on the show instance because, I want to write it like a list. So the only way I can write it like a list is, putting some sort of brackets around it, but I don't know how to call it recursively, right? Because if I just write show t plus plus show ts, then I just start embedding the brackets. So I'm having a hard time getting it to type check down here. The type error is a very confusing one. Expected type hlist tts, but we get ts2, which I suppose makes sense because and our ts is the wrong ts, so we're getting the type signature is wrong. I think I need to write more Go functions that deal with this case. So I'm just trying to understand how the heck I actually do that. That's sort of where I'm at. Yeah, that's what I thought too. Here, right? This for all. That's what I thought, but it doesn't fix the error. And let's see if the error T. What? I've never seen that. Okay, just as long as I'm not crazy, I'm just making sure. I think it's supposed to be like this, right? But then the weird thing is that I don't get. Oh, that's okay. No worries. Oh, I don't put this here. Oh, I see. I'm supposed to put this. Where do I put this? Here, I guess. Interesting. I didn't know that was a thing. Okay, that gives me an interesting error. All right, and then I need. Now we're getting somewhere. I see. I didn't realize I could even do that. Missing a parenthesis. Monomorphized. I see. Would it be better if I used a let? Is the same? I've never heard the term monomorphized, but do lets give me the same problem? Same problem, of course, right? You can't just easily get across it. Okay. But now, yeah, now let should not be generalized. Let me add that to my list of things because, well, actually, let's just Google it because it'll be easier in the long run. And I'll just bookmark it for now. Let should, oh, thank you. It makes my life a lot easier. From the master himself. So let's just put this in my Haskell bookmarks for now. I think I actually have a papers bookmark. Let me make sure. I guess I don't have a papers yet, so we'll just put it in Haskell. Not be generalized. Oh my gosh. Can't spell. So this is mono. I'm gonna put in quotes monomorphized. Will I learn about monomorphized in this paper? Because I'll read it. I ain't scared. Okay. That should be useful. Too many links. Let's move this in here and go back here. All right. So, okay. Monomorphism restriction. And then I think I just need to get rid of this probably. No. Show T. So I suppose I need to terminate this, right? Is that the problem? Both of them? Probably. The error I had before was like that it didn't have show. This is the thing that I think is like the problem is these aren't the same T's, right? Don't these need to be this T and this T need all the T's need to be the same. Otherwise this doesn't work, does it? Okay, we can try that. I'm into it. Yeah, so I think this is the problem. The T, because of the monomorphism restriction, this T, TS, and this TS are different. So I can't actually, you know, compare what I need to, or compare is not the right term. I can't get the right type for Go because these T's are different. So I'll never be able to deal with this problem, I think. So I don't see how I solve this. I don't see how I solve this. What if I introduce... Well, no, because we still have the monomorphism restriction. Even if I add... So what I was thinking is, what if I add two more... Nah, that's not going to work. So is it just not possible to do this? It feels like that's the wrong answer, right? It feels like it's the wrong answer to say that one cannot do this. But by just for contrast, so that we're all on the same page, whoops. If you write show t ts equals show t this compiles fine, right? And it's actually, I don't know why it is. It seems like these t's are not the same. Oh no, they are the t's. Sorry, they are the same t's because I'm using scoped type variables. There we go. I got it out. So the question is, yeah, this is very tricky, actually. There's got to be an answer. Like, there has to be a way to do this, or maybe there isn't. Maybe you just want to do like, no, even if you put hlist here, you have the same problem. You'll just start embedding hlist. So this is the only, I don't want to say it's the only way to do it, because there's no doubt in my mind that as soon as I look at the answer, it's gonna be, Sandy has figured out how to do this, I bet. What do you think? Do we want to take bets that I can't do it, but Sandy can? I bet you that's the answer. I'm gonna look. Let's look. The nice thing is we have answers, so I can actually make sure that I'm right sometimes. So 5.3-II. Oh, you know what? Oh, wait. Yeah, okay, so it's pretty close, actually. So let me show you what Sandy did, because just for reference. So this is what Sandy wrote. Actually, let me, what did I just do? So let me show you. So this is what I wrote, and then this is what Sandy wrote. So I don't think it's possible to do, which is good news. Like, I'm not insane. Colon sharp, like so. It's got to be like this, right? Wait, how does that work? Yeah, it's more or less the same thing, exactly. But technically, he wrote this. That seems like a typo. Yeah, I think it's supposed to be like that. Yeah. Yep. Yeah, and these are just strings, so yeah, I think it's a typo. Okay. Cool. Anyway, I wasn't wrong. So we learned something about this, though. That's cool. So let's write a note in here. So let's get rid of this and get rid of this. I actually do like using this symbol instead, because it sort of gives it away that it's correct. So due to the Haskell monomorphism restriction, one cannot use where or let to keep T and TS as the same types as the signature. We'll think about this if this is actually correct. One cannot use where or let to keep T and TS as the same types in the signature, and therefore you cannot write go, or therefore go can't compile. And then let's put this below. So we'll use stars. Need to learn a bit more about this. Star star. Okay, cool. We learned something. Oh, Nick, I want to try my best to remember that. Thank you for the follow. Really appreciate it. We're actually almost to affiliate, which is pretty cool. I never thought that anyone would actually be interested in watching this. So, you know, pretty happy about that. Okay. So now we also have to write an ORD instance, which I suppose could end up being tricky, but I'm going to guess that it's going to look very similar to show. I wrote derp. ORD H list, and actually I suppose this one's easier in theory because it's basically just their it's essentially just this with whatever function goes in ORD, which for whatever reason I always forget. So minimal is less than, sorry, compare. We'll just use compare. So compare. What are we comparing? We're comparing two H lists, right? So T TS compare T prime TS prime T compare T prime what does this return? An ordering? I suppose you can just do this, right? TS compare TS prime. Yeah, that's what I thought. I didn't think this one was going to be very hard, but you know, it's worth just implementing it for the giggles, if you will. Now the question is it right? I suppose we can do that real quick. So reload. So if we had list 1, 2, 3, compare 1, 2, 3, right? We get eq. Yeah. So if we do 1, 2, 3, compare 2, 3. Well, it compiles, but it doesn't work. Oh, I probably explicitly have to bind these to integers, huh? Um, oh, I gotta put these in parentheses though, huh? Oh. Couldn't match expected type. Oh, I'm an idiot. I'm dumb. Sorry. Hang on. What are these missing? It's very obvious once you realize it, but you know, sometimes I don't realize things. Oh. Oh, I have to compare the empty list. That makes sense. We're very close though, which is good. We just need to have our empty list instance. Board. Right? There's nothing else you can do. You can only compare h nil if you have h list empty list. Yeah, I think that's correct. I don't think there's any way you can have a different you can't have different data constructors. There you go. Cool. I need to grab a quick glass of water. I will be right back. Very thirsty. Not drinking enough water today. All right. And we're back. Oh, some other things I noticed when I got on today is that Soding followed me, which is cool because he's sort of one of the more regular Haskell streamers. And someone else, I'm not sure where the separation is, so I'm just going to say Senchayan Maiti also followed. So we got 2 followers while we weren't streaming, which is cool. And Oren's here. What's going on, Oren? How are you? I don't know if you were here for were you here last stream? I can't remember. I'm very forgetful, unfortunately. All good? That's great. So Nick is internet famous. So he should be hero. Hero. What do you mean by that? Yeah, yes. I guess so. In our lists, we're heterogeneous, yeah. Did I spell it right? I just realized I probably spelled it wrong. That'd be pretty funny. No, I spelled it right. Okay, so it says in here that the reasons we had to write 2 hasn't Pride weekend already happened? I actually don't know when it is. I just made it I thought it had already happened. I guess it's the entirety of the month, right? So the last weekend? Ah. That's great to hear. Just in time for my birthday. Okay. Let's see here. Okay, so where is this? Okay, so here we had to write 2 instances for eq to deal with the empty list problem. Yeah, Sunday. We're gonna be streaming like all day on Sunday. Well, I mean 2 4-hour slots essentially, just for something different to do. We're gonna probably start our first project, which is pretty exciting. I want to build something with servant just to do it because it looks cool. But we're gonna do the tutorial first because that's what we do on this channel, is learn stuff. Okay, so apparently you can do something to get rid of this problem by adding a type family. And then you okay. So this is what Sandy writes. So type family all eq ts type constraint, where really just started pouring. All eq empty list is unit. All eq t equals eq t all eq ts. Okay, so what does this do for me? This just means that I can write, instead of this long thing, I can replace this with what? So I think this means that I can, let me comment this out for now, that I can write this. No. All eq ts like that. And then in theory, I don't have to write this instance. Hopefully that's correct. So I don't need this anymore. What did I do? Okay, so I assume that I can't. Right. I need eq to do ord. So let's just comment out ord for now. And then see if this works. I'm mostly just curious. So I should be able to write what? H nil. No. Oh, right. Right. I just need to implement the case where you have H nil. This. I just didn't have the pattern match. Cool. And then you can write like 1, 1. Yeah, there you go. Cool. That saves you a little bit of time, right? And then apparently you can do this even more polymorphic by using something called Constraint Kinds. So let's go get that. I'm an idiot. kinds. Oh, I already have that. Okay. So now I can write wrong button. All. Oh. This is now C type to constraint. And then C CT ET all CTS. Cool. Then we can get rid of this. Well, we don't need to get rid of it. We just write. What do we write? All eq ts, and that's it. Okay, cool. We don't need this anymore. Suppose I should comment it out or something. Let's do that and come back to it. So here we can get rid of this. Well, I guess I need this line, don't I? We'll put that there. Get rid of that. Then we can write all show ts. That should compile. And then we can do the same thing down here. All do. Cool. Well, I guess this is right. The only thing that I'm confused about is why I need the all eq instance. It's kind of interesting. If I just do that, it's fine. Doesn't all ord imply all eq? I guess not. Seems like it should though. Not really sure. All right, so I guess that's chapter 5, constraints and gadgets. That's pretty sweet. We're gonna have to come back to this and think about this probably again sometime, but we can do that. Oh, cool. Okay, so we're done here, so let's move on. I think the next chapter is probably going to take a little bit of time, so it might span over 2 streams. Let's just make sure this builds one more time. Yep. I need my keys. Hang on. Okay, back. Alrighty, so let's start chapter 6. So in chapter 6, we're gonna do RankNTypes. Chapter 6. We are gonna put in the README the name of the chapter, RankNTypes, and we will simply pop this thing open and start coding. Well, we gotta clean this up as usual. I noticed somebody just hopped in. How's it going? Hope your day is good. Tell us what your experience with Haskell is if you are so inclined. Oh, okay, so there we go. All right, so we're gonna start with a motivating example. So if we had this function, with this function, this will fail because it doesn't understand, what's the way to say this? Okay, so what we're trying to do is write a function where we can pass it id and have it apply to 5. But as it turns out, that function is not trivial to write because you can't just write a to a. So, and the reason for this is apparently that the Haskell type system isn't actually polymorphic enough, which is kind of a funny way to say it. So the way you make this work is you basically increase the rank of this function. So this is a rank 1? We'll talk about ranks a little bit more, but I'm pretty sure that this is a rank 1 function. And it's also broken. So we'll write a broken rank 1 function. So to make this work, you have to increase the rank. So we're gonna say rank 2, a working. I think the ranks are right, but we'll you need to write for all a to int f5, and then we need to include some extensions to make this work. This one comes from RankNTypes. Look at that. So language RankNTypes. Okay. So now that you have this, you've increased the rank. So I'll explain rank a little bit more when we get to the part that explains how ranks work. But essentially what this means now is you can write Just a warning, it's thunderstorming here pretty good all of a sudden. So if I disappear, it's for that reason. So there's really nothing I can do about it if I lose power. And unfortunately, I lose power quite a bit in this house. So now we can write apply to 5 id, and we'll get 5 back. Okay? So we've promoted the rank of apply to 5 from 1 to 2, I think. We'll double check on that. And for that reason, I can actually put id here. Otherwise, I can't. This fails to compile. Okay. So the idea is this RankNTypes language extension makes polymorphism first class. Okay. So the rank of a function is the depth of its polymorphism. All right. A function that has no polymorphic parameters is rank 0. So I think what that means is rank 0 would be, I don't know, 5. So I think that this itself is a rank 0. I mean, is this a function? I suppose you can write it, we can write it as a function. Right. So, there you go. That's a rank 0 function. There's no polymorphism. And then it says, sort of all the other functions you're familiar with are 1. So this itself is a rank 1 function. Doesn't compile, but it's a rank 1 function because there's no polymorphic depth. Essentially, there's no embedded for alls. That's kind of, I guess that's the way to say that. So the only way you can get above rank 1 is by essentially putting for alls in parentheses. So that's a working rank 2 function. There's some talk about callbacks. Let's see here. The intuition behind higher rank types is that they are functions which take callbacks. So a rank 2 function will call a polymorphic function for you, while a rank 3 function will run a callback which itself runs a callback. I think that's very confusing to me, but that's okay. Lots of things confuse me. So here's another example. Can you hear that thunder? It's pretty darn loud. Oh, weird. Okay. That's fun. This is something new I've not experienced before. So I can't, so the only way I can do this is by erroring? Can I? Interesting. Okay. I guess we won't try to implement this. I don't even know how to create the stub for this. I guess you just have to implement it. Okay, now the real thing is that supposedly this is a rank 2. So does this mean that it's a rank 2 because you would implicitly write this with an extra set of parentheses because the R is embedded in the other for all. Is this the correct type signature? I don't actually know, but that's the only way I could see that it becomes rank 2. Is you have for all, for all. I'm not actually sure how to think about this. At the moment, anyway. Okay, so let's look at some other examples. No, yeah, so this is actually incorrect. Yeah, I do. So as soon as I turn the page, I realized that it's different. So they're actually supposed to be here. Okay, so it says here we can see that indeed the for all A is to the left of the function arrow, the outermost one. And so the rank of a function is simply the number of arrows its deepest for all is left of. I see. Okay, so it doesn't actually matter that this for all is outside. All that matters is that this one's embedded in this arrow and this arrow. So that makes it rank 1, 2, I guess. Yeah. Lumi, do you know how to just put a stub in here to make this compile? Do I have to like write undefined of undefined or something? Because I can't even write, like you can't even write this. Oops, what is going on? Okay. This doesn't work. This just fails. Just don't work. The error was just on the wrong line. I don't know what that means. Yeah, this is... Oh, I see what you're saying. Yeah. Oh, I can't even write... I see what you're saying. I can't even write a rank 2 function in Haskell. That's what you're saying. Like, it's not legal to write a rank 2 function. Sorry, rank 3. Excuse me. Thank you. Can't write a rank 3. I don't know what impredicative means. This is tough stuff. All right, well, anyway, we can keep going for now. So actually, let's put this back in here, though. This type signature is impossible to implement in GHC. It is called an impredicative type. Oh, okay, so it has something to do with the dependence between these for alls, right? Like if I write if I write, for example, just get rid of this for all. Oh, no. Same error. same error. I don't know what predicative means in this case, so we'll just leave it as that. Okay, so what is the rank of the following type signatures? So A that's one of them. Undefined. This is another one of these, isn't it? Yeah. So let's do this. Okay, so this one's rank, guessing, is this. So rank 2. And then this one is, it gives a hint here. It's right associative. So these are in parentheses. Does that imply that this is only rank 2 as well? Because the rightmost arrow is this one? I think so. But I'm not feeling very confident about this rank stuff. We got another one, actually. Hang on. MX. B. ZMA. So because it's nested twice, it's actually rank 3. Self-referential. Okay. Self-referential. I see. Let me make sure the parentheses are correct here. I feel like they aren't. We got MA. Yeah, they're supposed to be here. ZMAB. ZMXB. For all X, MX. Okay. So this is actually rank 3. So this is 3. This is 2. Is that extra set of parentheses? This. So this is embedded in 1, 2 sets. I think this is also rank 3. I think so. I'm not sure. Let's look at the answer. This rank stuff is a little weird to me. That one's rank 1. Okay. So it says that this one's rank 1, which bothers me. So this implies that somehow the parentheses actually go here. But I'll be honest, I didn't know you could write this. This one you can actually put it undefined here, so. So if it's like this, then it's rank 1 because there's actually, oh well, no, in both cases it's rank 1, right? It's not to the left of any arrows, so it has to be rank 1, no matter where you put the parentheses. Doesn't matter if you put them there or inside. It's not to the left of any arrows, so that's rank 1. That makes sense actually. Yeah, it's just wrong. And then of course this one's rank 2, just to screw with me. And the other one's rank 3. So how is this one written? As such. Oh, like just the type signature? I have no idea. Probably because the those parentheses are implicit anyway, right? Adding them there is you're providing more clarity, I suppose. Anyway, that's rank 1. I feel like, hang on, I want to come back to this. I feel like he tricked me because in this case, hang on. That there, we might need that again. So he writes in the book, A to B to C is actually parsed so I added that extra set of parentheses, right? That's what I did, and then that turns out to be incorrect because this is actually rank 2 apparently. I find this really hard for me because it doesn't, I don't know. The other one's actually rank 3, but this one's apparently rank 2, and I don't quite understand why. This hint threw me off. No, because you can write it this way, right? That's why it does. That's why it's fine. So even if you saw this, right? This would be like this, for example. And then you're okay. Right? Then we're only to the left of 1. We've not embedded in any more parentheses. So this is probably like the correct way to write this. I think. I'm sort of just justifying why it's rank 2, because I actually don't know. But I think that this is probably the right way to write the parentheses. Okay. Anyway, sort of interesting. I think it's a little tricky for me, for sure. Okay, so now we're going to talk about the continuation monad. So you can say the types A and for all R A to R to R are isomorphic, as it turns out. Wait, I thought I couldn't write this function. So callback A. Wait, why can't I write this function? Oh, I only have one for all here. I don't have the second one. That's why. I think you need to put down the arguments in the definition. Which definition? What line? I'm not sure I understand what you mean there. What time is it, by the way? Okay, I do have a sharp cutoff at 9:30 today. As in the name of it. Oh, I see. You just write A equals undefined instead of AX. I'm confused, Lumi. I'm sorry. You just write A equals undefined instead of AX. I think I'm confused. I'm gonna keep going for now. Try writing apply to 5. Ah, but that works. So if I put this in parentheses, you think this, well, no, because those aren't, the parentheses don't go there, they go here, I guess, is the idea. Interesting. So yeah, I get it. Okay. Yeah. Okay. So let's see if we can write this one as well. So if it's rank 3, oops. Now this one's tricky. I'm guessing I need like something like this. We just... That was strange. This is pretty weird. I don't really have a good explanation for this one. I was making an assumption that somehow... Alright, I mean, this is the entire for all, and this is gotta be the A to B. Okay, so you have to, like, you have to separate out the piece that's the for all to be undefined. So if you pattern match on this, then you're fine. And if you pattern match on this whole thing in parentheses, then you're fine. I think that, does that make sense? Is that the way to think about it? Almost, because it's a little stranger in this case. Because it seems like I should only be able to write, like what you said before. It seems like in this case, if the parentheses are truly like this, then I should have to write like A of X, but maybe this, okay, maybe this fails. B. This will clearly fail, right? Yeah, I have no logic about how why this doesn't work. I'm a little confused. It's weird though, right? Like I'm not... This one's kind of strange, actually. This almost makes sense to me. Somehow we're separating off the callback. So this one's generating a callback, and this one's taking a callback. I think you say it that way. Not sure. Anyway, let's keep going. Otherwise, we're just gonna sit here and be confused. I'm thinking it cannot handle assigning the type to A as a value without it having a parameter or something. Yeah, that's fair. Neither do I. But it is interesting that you can like sort of separate these things out and make that work. Something about this one is seemingly special. I don't know what it is, but something about it seems special. Okay. This one goes to A. Otherwise, yeah. Run cont f equals let callback Okay. Now, these two things are apparently isomorphic with each other. How that's obvious, I don't really know. But apparently, because you can write these two functions, they are isomorphic with one another. I suppose you have to prove that that's true. Right? By writing these functions, it doesn't necessarily mean it's true. Cannot unify undefined with it. I don't know what that means. Kind of useless here, Lumi. This is pretty weird. Okay, so these two things are isomorphic with one another. Why is it doing that? Very weird. Okay, so intuitively, let's think about this intuitively. Why do we need this for all here? Why do I not have type checking either? I don't have any types in here. Oh, here we go. Yeah, so that's an A. That's an A to R. Something that takes a callback that mutates the A and, well, not mutates, but changes the A into the R. That's what this callback is. So we're waiting for this function. Okay. So given a function A to A, this F is an A to R to R. This is weird. This is a very weird function. That's what I was thinking too. Right? That's the only way that this works. But I guess you're giving it the callback it. Um, okay, so it says spend a few minutes looking at continue and run continue to convince yourself, I guess it's continuation, to convince yourself you know why these things form an isomorphism.